Welcome to Crestron Avia. This video will cover the creation and application of channel strips. The signal processing for input, aux, and output channels is defined by these strips. This concept is borrowed from the live sound and recording world, but it has tremendous value in the configuration of a DSP system. The channel strips consist of not only the type of processing objects, but also pre-configured settings for these objects. Let's look at how they are created and applied to your Avia DSP projects. The previous video showed how to open and edit a DSP object. However, we only use the default objects. There are additional choices for some. I can also edit an object in a channel strip for creating my own custom channel strips with specific parameters. Using the navigation bar, I will click the Strip Edit button. My DSP workspace is hidden, and I am presented with Channel Strip Editor page. This page is used to create, edit, and save my custom strips. There are also three kinds of channel strips that can be created here: analog in, aux return, and analog out. Changing the type of strips changes what processing objects are available in the editor window to the right. The top row makes up my channel strip. Some of the blocks, like the PEQ, can be changed out for other processing types, signified by the objects shown below the strip. Analog in strips have 7 options for the EQ block. They are parametric EQ, tonal EQ, graphical EQ, notch filter, band pass, low pass, and high pass. To change the processing type, click and hold the type you want and drag it to the channel strip at the top. It now shows the TEQ type. The dynamic and mixer blocks can be changed in the same way. After I have chosen my processing objects, I can double-click on the objects to set its initial parameters for my application. I'd like to create a channel strip for a lectern gooseneck mic. This is a condenser mic, so I'll open the gain block and apply phantom power. This mic needs a fair bit of gain, so I'll bring it up to plus 33 dB as a starting point. I'd like to leave channel strips muted just as a precaution when applying them to live systems. Next, I'll change the EQ to a high pass type, with a frequency of 125 Hz and a slope of 18. I'd like to apply some compression to this as well. So I'll set it to -20 dB and a compression ratio of 3:1. Lastly, I'll gate this input to keep out unwanted noise, -20 dB, 40 dB of attenuation, and I'll increase the release time. Now that my strip is completed, I will name it Lectern Mic with Comp and Gate. Then click Create Strip. I am prompted for a file name, which allows me to save strips into groups based on types of inputs, by application, or any other sorting method you prefer. Now that the file is saved, I see the file name in my palette. Expanding the group shows me the strip I just created. Now I want to create an output strip, so I start by clicking the analog output button above the palette. The editor window shows me all the options that are available for this type of strip. I'll choose the crossover for my first EQ and leave the second as a PEQ. I'll leave the two dynamics as they are. The crossover filter is a very useful and multifunctional tool. It combines high and low pass filters for a 2- or 3-way speaker system, along with 5 bands of parametric EQ for controlling the transition areas between the crossover points. Many other systems would require 2 separate filters, and I wouldn't see the effect on a single graphical plot. Then, moving over to the PEQ, I see I have 10 additional bands of parametric EQ for tuning the room. Since I have 5 bands in the crossover, I may opt to change this one to a notch filter to deal with feedback. The notch filter has tighter Q controls per band, down to 0.05, so I can make very detailed cuts without drastic consequences to neighboring frequencies. This output strip is going to deliver a stereo set of speakers in my conference room, so I want both to be processed in the same way. I could simply apply this strip to 2 outputs, or I can select the stereo option and control them both with a single strip. The objects increase their height and give me a visual cue that this is a stereo bus. The last change I'll make for this strip is in the output block. I'm going to increase the full scale output to plus 24 dB to drive my amplifier with as much input signal as possible. Note that amplifiers specify what this setting should be. I'll save this strip by clicking the Create Strip button again and name it Stereo Speakers. Since I already have one strip file open, the tool asks where I want to save this one. I can create a new file or choose the file I already have open. Now that I am done creating a few strips, I want to apply them to my DSP project. Clicking the Strips button in the navigation bar keeps my palette of strips on the left side but takes me back to my workspace. This is the strips page. Just like the strip editor, I can apply the 3 types of strips by selecting what kind of strip I want. You'll notice that the workspace shifts and zooms to the relative section. I want to apply my output channel strip, so I'll first check the analog out button. My palette shows me the file I just created, and my workspace snaps to the output section. I'll expand the strip file to see my strip. Click and hold the item, and then drag it over to output 3 and 4. Notice that the objects that are changing flash. Now those channels are bussed together, and I see the processing objects I defined in the editor. Opening one of them, I can view the default settings I specified. It's that easy. As you deploy Avia projects, you will undoubtedly create lots of strips based on your unique applications. Since they are not tied to the DSP or projects, you can share your strips with fellow system designers or installation technicians via email or your favorite cloud storage provider. I have another collection of strips I created for a different project. If I want to use some of those in this project, I can import it using this option in the File menu. Click Load Channel Strips, and then find the file. Click OK to open once it is selected. The Convert File dialog window displays because the strip was created for a different model DSP, most likely one without Dante, so it must move the data from the file to the strip compatible with this DSP. Now my palette shows both files, and I can apply them as I see fit. The next video in this course will explore how Crestron Avia DSPs implement presets and how those presets can extend the functionality of your newly created channel strips and DSP configurations. Thank you for watching.